All right, shown above is a slope field for which of the following differential equations. So basically, this is matching. When you look at a problem like this, the first thing you want to look for is the unusual slopes, right? So the first thing I notice is that the slope is 0, right? Since this is -3, that's -2, this is -1, right? So the slope is 0 anytime y equals -1. That's important. So what that means is that dy dx has to have a y plus 1 as a factor, right? It's definitely going to happen. If you plug in a -1 for y, you should get 0, right? So if we look at a couple of these, right, if I take out an x here, this has a y plus 1, so that's a contender. If I take out a y here, I get an x plus 1, so that's definitely not, right? This one already has a y plus 1, and this one doesn't have the y plus 1. So right here, just this piece of information tells me that it's either A or C, right? Second thing I notice is that there's also 0 slopes when x is 0. So the slope also seems to be 0 on all these spots at any time x is 0, which means that the other missing factor I'm probably looking for is an x, and it means my graph is answer A. There are other ways that you could spot this. A couple ways that you could eliminate answer C and D separately, right? Answer C only depends on y. So something like answer C, right? Answer C, since it only depends on y, just to spend a quick second looking at this, if something only depends on y, then what's going to happen is it's going to have the same slope all the way across, but then when the y values change, it'll have a different slope all the way across and then a different slope. But see how it's the same slopes all the way across, and that doesn't happen in this picture? By the same argument, when you have something like answer D that only depends on x, right? So answer D only has x's, right? If you see something that only depends on x, then it's going to have the same slope for every vertical line, and then like a different slope that's the same slope for this vertical line, and a different slope that's the same slope for this vertical line, etc. But it's going to have slopes that are all the same along a vertical line, and that's not what's happening here. These all vary depending on both x and y, which immediately eliminates C and D. So that's the idea, but the answer is A.